one, and a satellite is revolving in a circular orbit. This is a satellite. Mass of Earth, let it be me. This is a m naught. It is having an orbital speed, and this is the radius of the orbit. Now, if I decrease the speed of the orbit, what will happen to the? I'll decrease the speed of the satellite. Then what conditions will happen? What will happen to that orbit? It is going to describe an elliptical orbit here. The initial thing. What is the orbital speed? Gm by r, Gme by r. Is it fine? As the radius increases, orbital speed will decrease. And now, first thing. So this was the earlier circle, no? These diagrams are very important. Very good conceptual questions are there, where students find a lot of difficulty here. If I decrease this, it is going to describe an elliptical orbit with Earth as one of the foci. What is the speed? This is v1 less than v0. In fact, this should have been, if the speed were remain constant, it would have been revolving in this circular orbit. No, this will become r, no? This will become r. What is this distance? So this is from satellite to this is Earth. This will become r. The other distance will be like this here. So it's going to be elliptical orbit here. So when a satellite which is revolving in circular orbit, if I decrease its speed, if I make the speed less than orbital speed, it's going to describe an elliptical orbit. It is going to leave that circular orbit and is going to describe an elliptical orbit here. Now similarly, if I increase, I'll make diagrams little bit smaller because let me accommodate everything in one place. Now what will be the next case? So it is going to describe now, if I increase the speed, if there were no change in the speed, it will have continued circular orbit here, and this distance will be r. This will be r dash. Here r dash, earlier r dash less than r. Here I shall write r1 better. Call this is r2. So why it will happen? I'll give enough proof. So there's one basic necessity you should have. So if a satellite revolving in circular orbit, if I decrease or increase speed, what will happen to path? The path will be of this kind. Now, sir, I'll make, and what is the condition? This particular speed should be greater than v0, but should be less than escape velocity. No? Otherwise, what happens? It is going to this one. So less than escape velocity, but greater than v0. If I make equal to escape velocity, the same condition here, if I make equal to escape velocity, earlier it was revolving in a circular orbit. The planet is here, the satellite is here. I'll make its velocity equal to escape velocity. And then what will be the path? The path is going to be parabola. It will use circular path and it's going to describe a parabolic path here. Then if you make velocity greater than escape velocity, if the velocity of satellite, if you make greater than escape velocity, then it's going to be describe hyperbolic path. We don't discuss the last two cases because it's the mathematics all, it's not there for our level, no. So you can just confine to 1 and 2, 3. We'll be discussing numerical. So this is what happens. If a satellite revolving, there's a earth, center of the
Sir,
earth.
sir,
Ah,
is the path because of positive energy, sir?
that's all. No, the energy will become greater than 0.
Yes, sir. Okay, sir.
Fine. This condition is able to remember this one. So these are very important. Means sir, like, sir, in numericals, how do I can justify this? Okay, let's take one numerical. That's all. No? Better to take one numerical itself. Sir, how do you can say? Can you show that 1 and 2 at least means like a R1 and R2? How can we justify? Let's take one numerical. Shall I scroll down? Okay, read the question.